some vocabulary. So this is the last day of the review. I want to be as effective as possible, so just tune in. I'll be recording this, so if you're not able to get notes fast enough, that's all right. But just try and stay tuned in the whole time. Hold on one second. So there will be a vocabulary section of this exam, and it will be kind of extensive. So you have to be prepared to answer vocabulary questions. I'm not going to tell you specifically which ones you need to know, but I'm going to go over some vocabulary now, and it is matching, so that makes it a whole lot easier. It's matching vocabulary, so all you have to do is be able to match it, but you've got to know the vocabulary in order to match it. Does that make sense? Okay, so I'm just going to go over some words. So concave, convex. If I were you, I would just write that down. Concave, convex. Draw the picture. Okay. I think that's easy enough to understand, right? Concave, it's like when it caves in. Technically speaking, the definition of concave is that a diagonal can be drawn on the outside. Like that's a diagonal. It connects one non-consecutive vertex to another. And that gives us the first vocab word that I'm going to specifically define. Diagonal. A diagonal is a line segment that connects one non-consecutive vertex to another. Okay? Remember, consecutive means one after the other. So if this one and this one are consecutive, this one and this one are consecutive, these two aren't consecutive, so they're non-consecutive. So a diagonal is a line segment that connects one non-consecutive vertex to another. Do you want to get a drink or something, Olivia? Are you okay?
Yeah.
All right. Okay. A regular polygon. How do I know a polygon is regular? What do I know about it? Polygon is regular. What does it mean about its sides and angles? They're all the same. So what does that mean? All the angles are the same. That means it's equiangular. Equiangular means all the angles are the same. And do you know what the word is that's all the sides are the same? It's equilateral. Good. So a regular polygon is equiangular and equilateral. What about the side of a polygon? How do I know what a side is? Well, those are all sides of a polygon. It's just one of the line segments that forms a polygon. Bless you. One of the line segments that forms a polygon. Take out a pencil and paper, please. Well, that was a white pass, wasn't it? Okay. What about the vertex of a polygon? that is clearly the vertex. But what's the definition of a vertex? It's the common endpoint of two sides of a polygon. Okay? Any questions on that? All right, and quadrilateral is the next one. What's quadrilateral?
Shape with 4 sides.
It's a polygon with 4 sides. Okay. Good. And there's some more, but I just want to make sure you guys know those. All right. Now I want you to, I'm going to review some trigonometry stuff. Okay? Some trigonometry vocab. So, first, let's talk about SOHCAHTOA and what that means. What is sine? The ratio of what? Opposite side over hypotenuse. Honestly, all you need to do is write down SOHCAHTOA and you can see it right there. Opposite over hypotenuse. You see? You should just write down SOHCAHTOA on your test, and that gives you what the ratios are right there. Is that pretty clear? And I'm pretty sure at this point you guys can remember SOHCAHTOA after that song. Okay. What's cosine? The ratio of what?
Adjacent over.
Very good. The ratio of the adjacent side over the hypotenuse. Okay. And what about tangent? The ratio of what? Opposite over adjacent. Opposite side over adjacent side. Just like that. Okay. And these are all trigonometric ratios. Trigonometric ratios. And what is a trigonometric ratio? It's the ratio of one side of a right triangle to another. You see? It's either opposite over adjacent or adjacent over hypotenuse or opposite over hypotenuse. Okay. Any questions on these? Okay. Now, to do with trigonometry is angle of elevation. Angle of elevation is angle formed by a horizontal line and a line to a point above. and angle of depression is the same thing, but it's to a point below. So I'm just not going to rewrite that whole thing again, but it's the same thing. It's angle formed by horizontal line and a line to a point below. That's angle of depression. Does that make sense? Okay. Now, okay. So now what if I say kite, rhombus, rectangle, and square. All right. The kite or in a parallelogram. Let's start with parallelogram actually. A parallelogram has two pairs of what sides? Parallel. A rectangle has what? What are the angles of a rectangle?
490 degrees.
Yeah, 4 right angles. What do I know about a rhombus? What do I know about the sides of a rhombus?
Two sides are equal to
A rhombus is like a diamond. So a rhombus has 4 congruent sides. Marcus, headphones out. You know better. Where's your pencil and paper?
Right here.
Okay. Thank you. What about a square? A square has the properties of a rhombus and a rectangle, so it's got 4 right angles and 4 congruent sides. And what about a kite? What about a kite?
opposite angles.
2 sets or 2 pairs of congruent sides. And a kite looks exactly like a kite, right? This side's congruent to this side, and that side's congruent to that side. That's a kite. Okay, you guys got that? That makes sense? Okay. All right. So there's a whole lot more vocabulary.
What section? What section should we look at?
For vocabulary, just all those handouts, all those fill in the blanks and stuff.
So that one test where we had.
No. Just all the review packet that I gave you. All the fill in the blank vocab and just like any time that you saw something being defined, that's all on the table. Okay. Yeah.
For kite, does
Uh-huh.
it matter which two are congruent? Like, is it always the same size?
For a kite, for instance, it's like you're not gonna have like this side be congruent to this side and this side be congruent to this side. It's more than that. It's always going to look like a kite, basically. Does that make sense?
Okay.
Is that clear? It's not the opposite sides that are congruent. That's the key. And in Kite, it's not the opposite sides that are congruent. Okay? All right. What if I give you a problem like this? Okay? And I tell you this is 5, and this is 5, and this is 7, and this is 7, let's say. And I tell you this is 20. What would this be? 10. Yeah. Okay. This is always half of that. Does that make sense to you? Or if I gave it to you the other way, gave you this is 6 and this is 8, and that's 8 and that's 6, and I give you that this is 12, then what's this? Yeah. Is that pretty clear? Okay. Now, exterior angles. I already went over this, but I want to go over it again.
Do we have the graduation?
No. Exterior angles. Let's say I give you a shape like this. First off, what kind of shape is that?
Hexagon.
Hexagon. And I know it's got a hexagon because it's got 6 sides, right? What do I know about all these angles? What are they called, first off? Exterior angles. They're called exterior angles because they're on the outside. What do I know is the sum of all these exterior angles? Yes. How do you know that? Well, look, the best way you can kind of remember it is it's going all the way around, and it's on the outside, so they add up to 360, right? So they add up to 360. So if they add up to 360, how much is each of them? What would you do?
We divide it by.
Divide it by 6, and you get 60. Does that make sense to you guys? So each one of these would be 60 degrees. Now, if I gave it to you a different shape, like a pentagon, like this, what do all the exterior angles add up to? Yeah, they still add up to 360 degrees, right? But how many of them are there? 5. So what would you divide by? 5. And that would get you 72. Does that make sense? Okay, is that pretty clear? All right. Okay, now trigonometric ratios. You guys need to remember this stuff. Say this is 35 degrees, this is x, and this is 12. How would I solve for x?
We have to do inverse.
The opposite
No.
of 35.
This is, you identify the angle, then you identify the sides, opposite and hypotenuse. So it's sine. The sine of 35 degrees equals opposite, which is x, over hypotenuse, which is 12, right? Multiply both sides by 12. Simple as that, okay?
You don't need inverse when you have to find the angle.
Exactly. So 12 sine of is 10.2. Does that make sense? Is that pretty clear? Okay. Good. Okay. Remember, you guys have to be able to find the volume. You're going to get the handout. You guys did pretty well on that test. Oh, which reminds me, I'm going to pass that out. Before the end of the hour. So please remind me if I forget. Okay, I've got to pass that out to you because I have that test for you guys. You guys did pretty well on that test. I was pretty happy about it. But you have to make sure you're able to find the volume. Okay, but one thing that you may not be 100% experienced with is, what if I tell you there's a sphere, and I tell you the sphere has a volume of 100, or let's say 500 pi meters cubed, how would I find the radius?
You do four thirds.
Well, I know that volume equals 4/3 pi r cubed, right? So if I already know the volume and I want to find the radius, I plug in the volume here as 500 pi equals 4/3 pi r cubed. Okay? Yeah?
What am I thinking with this pi squared is that
Area of a circle. Then I multiply by 3 to get rid of that 3. So I multiply both sides by 3. Does that make sense? And this becomes 1500 pi equals 4 pi r cubed. And then what would I do next? Divide by 4 pi. Right? The pi's cancel out here. You get 1500 over 4, which is 375. You get 375 equals r cubed. And this is where a lot of people, I had a problem almost exactly like that on the most recent test. That was the bonus question. You guys remember that? Okay. So you do this, but now in your calculator, you have to know how to do the cube root. Okay? So everyone pull out your calculators. If you don't have a calculator, then I'm sorry right now. But I'm going to go around and show everyone how to do the cube root on their calculator. Okay? The answer is 7.2 because I have to take the cube root, not just the square root. I take the cube root because that cancels that out and I get r equals 7.2. So pull out your calculator now and I will show you how to do the cube root. So all you do is do 3 second. See this one? Bam. Second. You see it's like x square root. So that makes it the cube root of 375.
Wait, so you did 3.
No. Because it's second. 3
Oh.
second. 375.
you know,
Okay. Look. You don't use that button. You use this button. You see that? So you hit 3 second. Bam. 375. See?
I can't see everyone.
So you hit 3 second. This one.
Steve lost
375. So you see how that makes it the cube root?
Oh,
Does that make sense?
There's probably a few more, but I just can't.
So 3 second.
But maybe it's
This one. 375. You see that? No, it's not the regular square root. It's 3. This square root. You see? 375.
That's crazy.
This. 3 second. This one.
Actually, no, that's actually. I mean, it's not even that. I don't even.
Oh, you do 375 second. This one 3. That gives you the cube root. You do 375 second. That makes sense? You do 3 second. This one. See?
do cube root.
Yeah. Oh, that thing? That you're Thank you. Thank you. Okay. Shh. All right. If you need help with your calculators in the exam, I will help you. I'm not going to just tell you how to like do your problem. But if you're like, I forgot how to do the cube root, I'll help you. But I'm not going to just tell you, oh, you have to do the cube root here. You understand? If you ask me how do I do the cube root on my calculator, I'll tell you how to do the cube root. I'm not just going to tell you what to do. You understand what I'm saying?
Is that formula on the cheat sheet?
Yeah, the volume formula is on the cheat sheet, yeah. Yeah, okay. All right. Now, all right, let's go a little bit. Oh, I'll get to that at the end. Okay. Let's say I give you a set of points 2, 5, 7, 3, and 1, 4. And I tell you the dilation is 2x, 2y. What would you do?
So you would
Let's say that's A, that's B, by the dilation, right? But what do you name the points? It's not A anymore, it's A what?
With the apostrophe.
Prime, good. So it would be 4, 10. B prime is 14, 6. And C prime is 2, 8. Does that make sense to you guys? Okay. All right. Okay. Cool. Now, at this point, I just wanted to make sure because I just want to make sure that I highlighted those areas. Because I want you to be able to remember them. But now, let's kind of return to our packet. Okay, so pull out your packet again because there's some specific sections that I want to hit. Yeah.
Will you provide us like our paper with the formula?
Yeah.
Like a note?
Yeah, that's the cheat sheet I was talking about. So, if you turn to section 12.2, we're going to start reviewing arcs and chords. And this was that chapter 12 test. So, if I give you some circle, and tell you this is the center of the circle, and I tell you this angle is 35 degrees here, right? What's the measure of this arc? If this is a central angle, what's the measure of that arc?
Oh, you add
360.
It's just 35 degrees.
Oh.
Measure of that arc is just 35 degrees. The measure of the arc is different than the arc length. Now, what if I said that the radius of this was 4, and then I asked you for the arc length? Then what would you say?
8.
It's 2 pi r, which is, remember the circumference of a circle is 2 pi r, right? So it's 2 pi r times the angle over 360. You guys remember this? So you just plug it in. What's the radius? 4. What's the angle? 35. So it's 2 times pi times 4 times 35 over 360 is 2.44. So the arc length is 2.44. Does that make sense? And this is actually more, sorry, it's section 12.3 is where I kind of go over arc length. Okay. Now, what about if I asked you for the sector area? Or I tell you I have a pizza, and I get a slice of pizza and the angle is 35 degrees. What's the area of that pizza? Well, first you have to know the area of a circle. What's the area of a circle? Pi r squared. Okay? So the sector area is pi r squared times theta over 360. You guys remember this? So it's pi, the radius is 4 squared, the angle is 35 over 360. What? Yeah, it is. I'm just kind of going quickly through it because I want to make sure I hit everything. And it's 4.9. What? Okay. Sure. Sure. Let's take a stretch break real quick.
Can I go to, let's just do it.
Go ahead. Go ahead. Go ahead.
Oh. No, because next block I have to finish.
I mean, if I have time at the end, but if you want to study, use these 3 minutes right now.
Yeah.
What? Yeah. You're welcome.
Yeah, like I have to finish a final. Yeah.
I'm happy this is the last semester. The fact that we're juniors in our grades matter like a lot now. And they're gonna get like all eights. You know it's like that. Too much intelligence is so strong. When I started my French exam, I don't know anything. How do you screenshot? Did you do this?
We'll have you, it was like a group effort, so we'll have to try one.
Okay. Let's not lose focus though, guys. let's not lose focus. I did that so we could stretch. All right, let's close computers, put everything away. Now, you guys got to remember this. Sector area is just the area of a circle, which is pi r squared, multiplied by the angle divided by 360. See? That's what sector area is. Okay? Now, everybody turn to this page in your packet. It's in lesson 12.5, the very end of lesson 12.5. Turn to this page in your packet. Okay? 12.5, it's like the last page of 12.5. There you go. Okay?
This one?
Yeah. Now, this is our guide. Look. If I have an angle inside of a circle, what is this called? It's an inscribed angle. And if this is 120, then this angle is half of that. You see the difference? If it was a central angle and this was 120, then this would be 120. You see? But since it's not in the center, it's on the circumference. Yeah?
No, I have to finish. I was going to you.
Okay, I'm probably not going to be done. So just go right ahead. So this angle, since it's inscribed, is half of the arc. You guys see that? Another way I could think about it is if I tell you, for instance, this is 24 degrees, then what's the measure of this arc? 48. You see? Either this is half or the arc is double. Now, what about if I have something like this, where two lines intersect? I tell you this is 44 and this is 86. And I ask you for the measure of this angle.
If it's half,
Well, x is not half, it's half of the sum. Because you have two different angles, you add them together and you take half of it. So that would be 130 over 2 is 65 degrees. Does that make sense to you guys? If it's like an x in the middle, I add them up and I take the average. I divide it by 2. Yeah?
I was going to get those tests.
Yeah, I've got them for you. Okay? And the last thing is if it's like this and I have this angle, I say this is 45 degrees and this is 125. If it's on the outside, you see, this is outside the triangle, then x isn't half the sum, it's half the difference. You see? So it's half of 80 degrees, which is 40 degrees.
So then you do 45 minus 25, divide that by 2.
125 minus 45, and then divide that by 2. See? Okay? So that's why this sheet comes in so handy, you see? Because if it's on the circle, then it's just half. If it's an x in the middle, it's half of the sum. And if it's outside the circle, it's half the difference. Does that make sense to you guys? You got to remember that, though. So you got to really study that. Okay? And the last thing is lesson 12.6. Okay? Lesson 12.6. All right, now, lesson 12.6 has things like this, where you're trying to find the value of the segments, the length of the segments. So it has one like this, x, 8, 6, and 5. Well, if it's an x in the middle, then it's x times 8 equals 5 times 6. You see?
It's 4.
So 8x equals 30. Then you divide by 8. And you get x equals 30 divided by 8 is 3.75.
What is it? You know rounded?
No, because that is an exact decimal.
Like, why did you do x times a and times 6?
It's this one times this one equals this one times this one. You see? It's the red times the red equals the blue times the blue. Simple as that. You see? Now, if it's on the outside, it gives an example like this. It says this is Z, this is 13, this is 9, and this is 30. Okay? Well, in this case, it's the exterior times the whole thing. So it's 9 times 39 equals the exterior, which is 13, times the whole thing, which is 13 plus Z. You guys remember this? It's the exterior times the whole thing equals the exterior times the whole thing. So in this case, it would be 9 times 39 is 351 equals 13 times 13 is 169 plus 13Z. I subtract 169 from both sides, and I get 351 minus 169 is 182 equals 13Z. Divide both sides by 13, and I get Z equals 14. Does that make sense? Thank you. Thank you. All right, and the last one is if I have a situation where it's just like this, like I have a line and then 2 line segments. So it's like 7, Y, and 10. Or let me do the other one. Like this. So I have a situation like this. X, 4, and 5. In this case, there's only one number here on this line, so it's just that number squared. You guys remember that? If there's only one, it's that number squared, equals the exterior, which is 4, times the whole thing, which is 4 plus 5, or 9. So x squared equals 36. Take the square root both sides, you get x equals 6. Does that make sense to you guys?
Yes.
All right, that's the last thing I want to cover. One more thing. Sorry, one more thing. If I give you a triangle and I tell you this is 40 degrees, this is 50 degrees, okay? Or I say this is, I'll make it more realistic, this is 60 degrees and this is 50 degrees here. How would I find the third angle?
Equal 180.
Add them up. 60 plus 50 is 110, and then subtract from 180 is 70. So that's 70 degrees, right? You guys remember that? Guys, please don't pack up yet. That's distracting. Thank you. Okay. Now, let's say I say this is A, B, C. Which is the shortest side? This is the smallest angle, so opposite is the shortest. Right? Which is the middle side? BC. Does that make sense? Because it's opposite the middle angle. You see? And which is the longest? AC. Good. Does that make sense? So if I asked you to put them in order from shortest to longest, it would be AB, BC, AC. Does that make sense to you guys? Any questions? All right. That's it. Good job. I'm going to hand out the test now. We're done for the day.